Do you remember when promises were released? Our lives got so much easier after that. We had more time to ourselves, we had more time to our families, instead of debugging those long and messy callback, asynchronous requests chains. And that we have finally tamed the callback hell monster. It was literally heaven on earth. Okay, exaggerations apart, the concepts of promises were a great addition to the JavaScript ecosystem. It made our code, our synchronous code, more linear and way more predictable. In the meantime, the JavaScript community was adopting more and more the functional programming concepts. So concepts like pure functions and single source of truth and immutability have helped us to reason more about our code base and to maintain our sanity. Those are now basics for every new serious development project. But as the development practices, the web also evolved. Websites are more and more interactive, and this makes it very difficult for us to deal with every single scenario that users can face while using our websites. So when imperative programming starts failing us, that's when we look for alternatives. And that's where reactive programming and the concepts of observables come to rescue us. So, hello, ich heiße Guilherme. That's my full German vocabulary. And I'm a full-stack developer at Motorway, as Juan said. And I moved to Berlin 10 months ago. I do not work with Angular right now, but at every opportunity I have, I try to sneak RxJS and observables into our stack. I will be successful one day. So before we can dive into the observables topic, we have to understand why they exist and the concepts behind it. Reactive programming. Reactive programming is not a new subject. It's an established programming paradigm dating from more than 20 years ago. It was mostly used for animations and 3D graphics because developers could not be concerned on how the animations and the graphics should be working, but instead on what should be working, because of it would be more abstract and more productive for them. And that's the first property that clashes with what we know today. Thinking of what we want to accomplish instead of how to accomplish it. When we learned how to code back there by university or self-taught, we have to relearn how we think. We have to structure our code in a way that machines understand, step by step. This is the imperative mode of programming. That's not natural for us. If you, for example, think of scratching your nose, you won't think of lifting your right hand, going to your nose, scratching it 5 times, and then letting it go. No, you just think of doing it, and then the other steps are implicit. And that's how declarative programming works. You just declare what you want to do, and let the steps to do it be implicit. So you don't have to worry about them explicitly. I'll give you another example to make this differentiation better. So imagine you are in a restaurant, you are going to a restaurant, and then you approach the front desk with your and then say, in the imperative mode, hello, I'm here with my friends. I see that table there next to the bar is empty. I'm going to walk there and sit down. However, in the declarative mode, you would say, table for 4, please. So in the imperative approach, you are more concerned on how you are going to do to get the seat. So you list out all the necessary steps to get the table. But in the declarative approach, you are more concerned on what you want, which is a table for 4. The outcome will be the same. You will get the table. The steps you will take to get there will be certainly similar, but the level of abstraction in the last one is way bigger. So, of course, we can apply this to code. Here we have a JavaScript line that we can read. Let result be the sum of value 1 and value 2. So we're just saying that the result of the operation should be stored in that variable. So I have here just to illustrate a simple form. Nope. That has this, just to be visual. So I have two values. If I want to keep result updated, I have to explicitly say so by clicking on the sum button. If I change one, okay, I have to explicitly say it again. So it's way more, I have to control every single step. But if we think about this line in a declarative approach, we would read this as result equals to the sum of value 1 and value 2. This may sound similar, but it's not. By this phrase, we're defining that result depends on the values of those other two variables. So whenever those two variables change, result will change as a result, as a consequence. So for example, to make it visual, I have a form here that implements the declarative way, which is also the reactive way. So I have those two values, but as I'm defining that result must equal the sum of those two values, result will react to those changes. So this is just to have a visual way to say how a reactive variable, in this case result, would change as its dependencies change. So by looking at this, you may remember of another famous piece of software, spreadsheets. They are a perfect example of a reactive application. You edit cells, putting formulas on it, and referencing other cells, other dependencies. And as those dependencies change, the target cells change as a consequence. That's as simple as it can be. So to have the ability to react to ever-changing values, reactive programs have streams as the core data structure. So a reactive program reacts to interactions. These interactions are then mapped, they are shaped in form of streams, which are basically events happening over time. So let's illustrate that. With streams, time is always a dependency. Events are emitted in different points in time, and these events can represent anything. They can be DOM events like mouse clicks or input changes, as we've seen in the form, HTTP requests, or even data storage events. Anything can be a stream. So going back to our visual example, result here is a stream of numbers which depends on other two streams, value 1 and value 2. So to wrap it up, this section, reactive programs are declarative. When we're thinking about our problems, we think of what we want to resolve instead of how to resolve it. And they are based on streams. We think in terms of streams to design our code, and in a way that instead of holding on to data, we allow it to flow through our application and apply some transformations along the way, making them behave as we want to, as we've seen in the result sum operation. So these are the concepts, and there are tons of libraries implementing it. And Angular chose to incorporate RxJS into its core, which is by far the most popular lib in the moment. RxJS is part of a bigger project, the ActiveX project, which means reactive extensions. It all started in 2007 at Microsoft, and as years went by, the framework was being ported to other languages. So if JavaScript is not your main language, you will find an Rx implementation in your favorite idiom. So as we know, RxJS has observables as its stream data structure, data type. And observables can emit three types of notifications. Next, called when there is a new updated value. Complete, when no more data will be pushed down the stream. and error, when an error occurs while processing data, and also indicates that no more data will be pushed down the stream. Now, an interesting fact about observables is that anything in computer science can be represented as one. So by being able to set up, send any number of values over any amount of time, and tearing down, freeing up resources, we are able to represent animations, messages arriving over a network, the complete lifecycle of a view, and many other situations. It's a consistent API that supports anything that you may need. So let's say we want to port the geolocation API to be consumed as a stream. We first set up the listeners to receive updates on every position change. So we map the next, the update callback with the next call, and also the error, may any error happen. And in the end, return a tear-down function intended to clean up resources when we don't need these updates anymore. And this is how we would use it. We subscribe to it by passing an observer object with all the notifications we want to observe. By subscribing to an observable, we receive a subscription object as return, which we can later use to unsubscribe from it if we don't need the resources anymore and the data. So with this simple API in mind, we get to the reactive mantra. Everything can be a stream. This means that we can use observables wherever we want. And being able to represent anything as streams makes it possible to work reactively on any code domain. So before we can start thinking reactive, we have to consider the basic observable properties. They are lazy, cancelable, and immutable. They are lazy because they are not evaluated on definition. Here I'm defining an observable that emits 5 numbers, from 1 to 5, and then completes. If that's my whole program, if I don't do anything else, no further execution is made other than defining a numbers variable. This makes observables very different from a promise, because they run their content as soon as we define them. Whatever you write in the observable body, it's not called until we invoke it. And as we've seen the geolocation API example, we invoke it by calling the subscribe method. Only then the stream starts emitting values. Another detail that makes them distinct from promises is that although they are great to control asynchronous code, they are synchronous by default. So if I put here a console log after my subscription, after I subscribe to it, those consoles will be run synchronously because right at subscription time. There are no undesirable surprises. Considering all these implementation details, in the end, an observable works just like a function. It only computes its content when we invoke it, which is when subscribing to it. They are also cancelable, which means that whenever we don't need this information anymore, we can abort this operation by unsubscribing to it. In this case, I'm using the Angular's HTTP client as an example. I subscribe to it, making a request, and let's say the user navigated to a different page, and then I unsubscribe to it to abort the operation. So I don't have any undesired side effects afterwards. And the last property in our list is that they are immutable. Any operation performed in an existing observable instance creates a new one. So, for example, if I want to get only odd numbers from my numbers stream, this code here won't suffice, because the applied filter operator creates a new observable. So subscribing to the existing one won't have my desired effect. Instead, I must either subscribe to the new observable or store it in a variable and then subscribe to that variable instead. This behavior here makes it very easy to compose observables, and that's the true power behind RxJS. With this, it is safe to reuse streams and transform them the way we want without interfering with other parts of our application that relies on the original stream, in our case here, numbers. The way we take the most advantage of this behavior is through operators. Operators is where RxJS really shines. They are functions that exist to facilitate the data manipulation in an observable stream. They are the pieces of code that allow complex asynchronous operations to be performed and composed in a declarative manner. So let's analyze our last code here. Here we are creating an observable using the off operator. This is a very simple one. It creates a stream that emits all the arguments it receives and then completes. In this case, it's the same as the observable I created by hand, but just more straightforward. The off operators falls in the category of creation operators. They create new observables with predefined behaviors. Then, to create the two other reliant streams, we use filter. Filter is a pipeable operator, so it needs a source observable to work upon, and then returns the new observable, which only emits values that satisfy the given condition, in the case of filter. These are two of the most simple operators in RxJS. You can see that filter is just like the array filter, so it's very easy to grasp. There are more than 100 operators in the RxJS library, so learning all of them at once is nearly impossible. I say nearly impossible because some people do it. It gets even worse if you're just starting with reactive programming as a whole. So my golden tip is learn as you go. Whatever the problem you are trying to solve, or however you want to transform your observables, there will be an operator up for the job. But if you don't know it, or just don't yet understand what that operator you found on that Stack Overflow answer, what it does, just fall back to imperative programming. Subscribe to your stream, and then do whatever you need to do in the end in an imperative way. You're not forbidden to do that, thanks to JavaScript, multi-paradigm. So now that we know the basics, I want to show you a quick example on how to solve problems by thinking reactive. So let's apply it to our initial example, the super summer form. So the problem definition is very clear. When either values change, we should update the result input with the sum of the two other values. So we first have to identify the events that are dependent. Again, thinking reactively, you have to identify dependent events that interact with each other. So here it's very simple, very easy. Value 1, value 2, and result, inputs, changes, and values, they are interconnected. So here, I will start with the very basic logic. No DOM right now. So just create two streams with two static values. So value 1 and value 2 is created, so then we can create the result stream. We are using here combine latest, which creates another stream with those two values combined. So just to make it very clear, combine latest is another creation operator which combines, as the name suggests, the latest emissions from the input observables, and then emits one value with all those values in a single array. So then we have here our result stream with those values combined, but that's not what we want. We want them to be summed up. So then we use another pipeable operator, the map operator. Here we get the values, which is a array, and sum both of them. But as we can make it a bit more clear using array destructuring. And that's it. We have our 3 observables, our 3 streams, doing what we want, like in a very readable way. We get those 2 values, combine them, and then sum the results, the values, to get the result. But this code here, it doesn't do anything. It's just a recipe. If you don't subscribe to it, it won't do any computation. So to have the sum, we just subscribe to it, and then it will do the job. Okay, this works, but it's static. We don't want it. We have to create a form. What do? We use a helper function from RxJS to create a stream from DOM events. So now we have a stream from events. The first argument would be the target element, and the second argument would be the stream, the event name. So now our value 1 and value 2 streams, they do not have what we expect. We expect them to be numbers, to emit numbers. So we use again map to get the value from the input. But here we have like 2 lines with the exact same code. We can improve that and still be readable. You still keep it readable. But first, let's take a deeper look on how operators work. So let's focus on the first stream, and then let's look at the operator contract. An operator is simply a function that receives a source observable and returns a new observable. Again, observables are immutable. In the case of map, it's a factory function to create operators, the map operator. So it receives a transform function and returns a new function, which is the real operator. So knowing that, we can use it's kind of anchoring and create a specific map function for us. I would call it toValue. And then, by knowing that an operator is just a function that receives a source observable and returns a new one, we can do this, like calling our new operator with the source event, the source stream, but that's not how you should do it. Just use the pipe operator to keep on the standards. So knowing that, we can go back and fix our code. So now we just created a custom operator. That's mostly how we will do, like 90% of the times of new operators, it will be reusing RxJS operators. And it's still readable, but we still don't have our desired output, which is to update the result input. So it's just every time we have a new result, we update the form input. So the takeaways from this example is that RxJS operators are just factories. You can reuse them. It makes it even easier to apply composability. And RxJS has a lot of stream creation helpers. Like the from event we just seen to create a stream of DOM events. Off, which creates a discrete list of values and then completes. There is the bind callback and bind node callback, which creates a new function that from the good old callback style of functions, and it creates a new function that returns an observable instead. So when the callback of that function is called, the observable is emits a new value. And the from function, it creates an observable from any iterable, like maybe an array, a generator, or even promises, as you can see with fetch. And defer. Defer is a very nice operator which creates creates an observable only on subscription time. And this was a very good thing I learned, because when you are porting old APIs, like not that old because they use promises, APIs that use promises, for instance, if you have a GitHub wrapper API and you want to make it reactive, you want to port it to a reactive code. If you do just, for instance, you have fetch users from GitHub, and it returns a promise, and you want to make it like an observable, to use it in a reactive way. But here, if we run this code, the operation was already performed. The request was already made, because the promises are eagerly loaded. So as soon as the promise is created, it's requested, and we will receive the data, but it will not have one of the main observable properties, which is observables are lazy. I didn't expect the request to be made. So we can use defer instead. So we pass a factory function to defer, and the request will be made only when the observable is subscribed, which will behave as we would expect from a stream. So this, when you are porting other code to a reactive way to make all your recipes, all your composability, this helps a lot on that. So in summary, everything can be a stream. So if you are working on a reactive application and you are dealing with some external APIs, third-party APIs, you can just port it to observables. And they are just functions. Don't need to be afraid of them. They are just functions that you can compose together and then get your values at the way you want. RxJS is best used to coordinate events, because you have all of this. The idea is that you have lots of, your application is always interacting with events, being them HTTP requests or user events. So RxJS is great to coordinate that. And another tip I would give you is like write down your problems, and even better, draw observables. Like pen and paper will be your best friends while fixing asynchronous code. So like, trends, they come and go, just as some frameworks do. But reactive programming is here to stay. Thank you.
Thank you, thank you. Thank you so much.